So yeah, I think we would have seen from the flyers and everything that this session is focused on how to improve the way you build your RAG solutions. And I believe most of us are familiar with what RAG solutions is something that we see almost everywhere at the moment, or even every day. X, LinkedIn, and so many blogs and articles all over about different ways, different chunking techniques, different prompt engineering techniques, and all that. So, but for this session, within an hour, I want to walk us through how we can actually improve the process of um, creating a knowledge base for our RAG solutions, right? This is just going to be introductory, so it's nothing too technical for those of us that are new to developing RAG solutions um, or working in ML generally. So yeah, let's get into it. Any questions? I believe everyone can hear me, right? Please, if you can't, just you can unmute and draw me back. All right. So I already shared the GitHub repo for the demo that we'll be having, a quick demo, and then the slides also in the chat. So if you check the chat, you should find it there. And if you can't, which is unlikely, you can just notify me, so I'll resend it. So I am Samuel Bangola, as you must have seen from the flyers. And okay, someone is trying my attention. Yeah, Favor, you can go ahead.
Okay, sorry, can you hear me? The slide and the link that you sent is no longer on the platform, or maybe it was, but I can't see, maybe because of the time that I sent it.
Oh, okay. All right. Is I think Miriam also joined after I dropped it. Is that the same for you too?
Yes.
Okay, okay, let me reshare it then. Okay, so I shared or resent mixing up the two links together. I resent the link to the repo, and then in the repo you'll find the slides there under a folder. But by the time we walk through that, you'd get it. So, but let's just get started. And then if you have any questions, you can just draw me back. So I'm Samuel Bangola. I'm a machine learning engineer, and I'm also a Gold Microsoft Learn Student Ambassador. And then, like I already introduced earlier, the session for today will be on how to use Azure Document Intelligence for OCR, which is Object Character Recognition, right? Or Optical Character Recognition. Yeah, sometimes I jumble the words together. So optical character recognition in RAG solutions, where we know RAG means retrieval augmented generation and not your normal like RAG for cleaning or stuff like that. So like I mentioned, this session is going to be very introductory for many of us that are new to machine learning or AI. So we're going to walk through some of the fundamental terminologies that will be used, or I mean, things that we need to know as we move on, right? So artificial intelligence is something we all hear every day, and then I'm sure it's an overflogged question or topic at this point. But then, just for completeness, right? We can say that AI, right, refers to computer systems designed to perform tasks that typically require human intelligence, such as learning, problem solving, and decision making, right? So you have so many things that you want to do as a human being, so many things. Um, Maybe that involves reasoning, right? I mean, or things that are repeated. That's where AI can come in, right? You want to automate some things, you want to speed up your workflow, you need to work on something, you don't know how to start, you use, for example, maybe ChatGPT to give a template of what you think would be helpful for you to get started on. Maybe you're writing a report or you want to analyze some sort of information and you don't even know where to get started. So many things that you can do with machine learning and AI in general, right? And there are different fields, or we can say different, fields where deep learning is like the core layer of how um, most models are built. When I say most models, I mean like most generative AI models, since that's the focus of today's session, right? It's about building generative AI models that leverage RAG technique, right? And then we have machine learning, which is like maybe a broader aspect of, you have your regression, your classification, models, and other different things. And AI generally is like an end-to-end full scope of everything, the solution, um, whatever, however you want to describe it, you get me. So moving on, we're going to talk about what are Azure AI services, because Azure Document Intelligence is one of Azure AI services. So I think it would be good for us to like discuss what that means in general. So Azure AI services are cloud-based AI services that help developers and organizations, create intelligent and market-ready applications, using APIs and all sort of things, right? So my first one to ask, like, what is even Azure in the first place before we even move to Azure AI services, right? So, well, Azure is a cloud service, basically. Let's put it that way. I think if you know AWS, or if you know GCP, that's the Google Cloud Platform, right? Maybe Cloudflare, and other applicant. If you're familiar with maybe Heroku, Render, for a few of us that might have a bit of knowledge into front end development, back end development, those are still cloud services, right? So Azure is also a cloud services, and one of the biggest too in terms of the services that it provides. So one of them, or one of the suites of services that Azure provides, is these AI services, and they include multiple things. They include multiple services or resources like the Azure OpenAI service, right? Which is like your typical OpenAI service, but then hosted on Azure. So if you have an Azure subscription, you can leverage OpenAI models like GPT, um, DALI, Whisper, and the rest of them within Azure. You have the Azure AI Agent Service, Azure AI Search, which is also something that you can leverage with generative AI. So you can, um, I mean, in this case now, what we're just applying is like, you're trying to create your own document, the chunking and everything, pre-processing it yourself, maybe to now use an open source um, vector store, or maybe an external vector store or something, right? Apart from maybe Azure Search, for example. So Azure Search in itself can have, or is, a vector store that you can leverage for your generative AI solutions or your RAG solutions, since that's the focus. So you have content safety, speech, document intelligence, which is our focus for today, the vision service, where you can also do some other OCR based things, um, facial recognition, different things, image classification, object detection. You can do that within the Vision service, language service, translator service, and there are a whole lot of them basically, right? But the focus for today will be on Azure Document Intelligence. So now, moving on, we have OCR and RAG, which is like our main focus of today. And I'm just going to walk us through what this means in as basic terms as possible, right? Um, so I have an image here, which a few of us might have seen me share about yesterday, right? On using Azure Document Intelligence for OCR, basically. And you can see here that what OCR means is reading, just like this is optical character recognition. They're trying to recognize things optically, right? It's not in text format. So let's say you have a Word document, right? Or you have um, a .txt document, right? That's in readable format already. So you're not extracting anything optically. I mean, if you are reading it, of course you are reading with your eyes. But if you want to like extract it, maybe you want to copy and paste, or you want to, you know, select some things, you can directly do that. But we know that when it comes to like maybe images or PDFs or things like that, you can't directly do that because it's not in a readable format, right? It's just, I mean, it's not in writable format. Yeah, I think that's the best word to use. So you have read and write, right? In generally, when you are dealing with documents, right? It's just in read format. It's not in write format. You can't add something to it. You can't copy something out of it. You get me? That's maybe programmatically or otherwise. So all we can see from this image is that Azure Document Intelligence has identified these certain regions in the document, bounded by the light blue lines, and then knows that, okay, these are the portions that have text, right? Of course, the whole page has text, but it now identifies certain regions. That, okay, this region has text that go together. This one have text that go together. Instead of just saying, okay, there's a text here, you just read it as it sees it, you just read it. It's just like, yeah, going from left to right, and whatever you meet on the way, you take it like that. No, that's not how Azure Document Intelligence approaches OCR, right? Does sit in certain regions or segments, you might want to call. So that's basically what optical character recognition means, right? You want to extract text, right? It might not be text, it might be images or something. You want to extract mostly text though, text from a non-writable format document like images, PDFs, and a few others like that. So now moving on to RAG, which I already shared, that is retrieval augmented generation. It's a technique, right, that is used to augment your text generation. So, for example, we know that to an extent, ChatGPT is maybe limited. Like if we take ChatGPT as context now, or you ask, let's say you're in school and you want to make use of your lecturer's slides or something, um, each time you have to upload maybe your lecturer slides to make sure that Azure or ChatGPT can have that context to answer your questions when you're doing your study or reading, you know. So, but with retrieval augmented generation, you can solve that completely, where you don't have to keep re-uploading your document each time. In fact, the process of you uploading your documents to Azure, to ChatGPT, for example, right, and then telling it to answer based on what is inside that document, it's in itself a RAG solution that you've done for yourself, like a simple RAG solution within that chat, right? And this is basically how it was, that we can see from the, will I say block diagram or um, yeah, flowchart or however. I mean, this is definitely not a flowchart, but let me say block diagram. So you have a user on the right hand side, and then he asks a question, which is query, the first query. Then that query goes into the knowledge base, right? Because that's what we're basically trying to focus on. I want to know how we can prepare our knowledge base to be more rich and more to make more sense if you are actually reading them yourself. Now, because computers cannot read like human beings, so we want to see how we can make them to extract the portions of the document like a human being that has eyes. I can see, oh, okay, there's a segment here, there's a circle here. That means the text and the circle are together, things like that. So that's what we're trying to do with Azure Document Intelligence. So now we're assuming that we've prepared all that with the relevant documents that is relevant documents to the use case we want to do. So let's say, for example, like I mentioned, maybe you're studying a course, and let's assume that course is maybe microprocessors and microcontrollers, right? And then you have different documents or maybe slides of your lecturers, and then you want to like prepare a simple RAG solution. So the process of you uploading all those slides to ChatGPT is you like preparing your knowledge base, right, with the relevant documents. And then when your query comes in, dot text, like, okay, what are microprocessors? It goes into your knowledge base. Basically, your knowledge base is now a vector store. In terms of you want your text to be searched properly, you want to prepare it that way so that you can use maybe semantic search, like it understands instead of doing like word for word search, it understands the context of your question and then it uses that context to set the knowledge base and return some things. So once it searches things that are relevant to your query and then brings it up, right? You can see the arrows. First, your query goes into the knowledge base, and then it now retrieves some relevant docs now, right? Let me put this way, some relevant docs of relevant segments of your knowledge base that are closely related to your question that you've asked, right? So you asked what are microprocessors, then it goes in, it says, okay, there's a part of its slides that actually, asks for definition of microprocessors. Maybe there's another part that talks about the types. Maybe there's another part that talks about some maybe examples of microprocessors. And it says, okay, these are the three most relevant portions of the slides. And it retrieves that, adds it to your prompt. So you can see query plus relevant docs, right? This symbol that was used to represent relevant docs. You can see query plus relevant docs, right? Will now be sent to the model, which is, for example, in this case, ChatGPT that we're using already, right? So, of course, that LLM must have been pre-trained already. So this whole process of pre-training is just, we're not focusing on that now. We know that we have a trained model, whether we're using GPT-4, GPT-4o, whatever it is, Llama, DeepSeek, whatever models you want to leverage. Then that is done. Then, of course, as LLMs work normally, when you ask a question, it generates a response and passes it back to the user. That is the whole flow of retrieval augmented generation. It's definitely something we do already within our chat with different LLM solutions, right? So let's move on to how we can actually build our own custom RAG solution for our own personal use case, leveraging Azure Document Intelligence. I have some resources that we can use to do further reading on our own. Like I mentioned, the slides are in the repo, and then we'll get started now into the demo. It's just going to be a quick one, so let's just try to follow along as much as we can. Like I mentioned, it's going to be introductory, but still, if there is something you don't catch up with, please kindly draw me back, and then we can move together. So this is the repository that houses the demo for today. You can, I mentioned that I shared the link already, but just in case you don't have it yet, so we don't slow ourselves down, you can just try and get this link. Maybe visit my GitHub repo, just some examples, and then it's most likely going to be the first repository you find under repositories. So let's dive right in. So now we have come to our Azure portal, which is portal.azure. That's where all Azure resources are housed, right? Or all. Then you can have some external links that take you out, like the Azure Documents Intelligence Studio and things like that, Azure AI Foundry, and so many other things. So, but when we come to Azure proper. Um, this is the home page, or this is the portal that houses all resources. So if you want to create an Azure document intelligence resource, how do you go about that? The first thing is, yes, come to the Azure portal, portal.azure.com, and then you have this click button here, create resources. So you can just go ahead and click create a resource. So once you click create a resource, you see a list of some sample resources that are recommended, or maybe most frequently used and stuff like that are recommended to you. But you already know what you want. So um, we'll go ahead and just search for document intelligence. Okay, that is load up. Right. So while this loads up, um, you can check through the repository just in case you haven't gotten access yet. You can check through the repository, and then for those that ask request to the slides, once you go to repository under docs, you'll find the slides here. So which is how to use, the title of the events.pptx. So that's how you can get access to the slides. So now, since this has loaded up, now we can now go ahead to search document intelligence, since we know the exact resource that we're looking for. So it used to be called Form Recognizer. That was changed about maybe a year and a half now. So yeah, about a year and a half. So if you might still find some resources online that refer to document intelligence as Form Recognizer. So in case you're doing some external research and you see Form Recognizer, that's the document intelligence resource. So you can go ahead to work with that. So now, even within Azure, the reference is still made there just for context, for probably people that have been working with it long before the name was changed. So we'll go ahead and then click create, right? Okay. So once we click create, we would have to create a resource group and give a name to our resource. Our resource is a document intelligence resource, right? So we have to create and give it a name. But in general, a resource group is, you can call it a repository. Just like when you have GitHub, a repository that houses all your codes and everything, right? Your README, your experimentations, maybe if you do ML with your notebooks and everything, right? A resource group is something like that houses all, you can use it to house all your services that you want to create for what you want to work on at that particular moment. Let's say you're building an application or something, so you can just create a resource group with that name. So all the things you want to use, maybe you want to deploy a web app, you can create the Azure App Service resource. You want to use the container services, you can create an Azure Container Registry, or Kubernetes services. Everything you want to do, you put in that resource group, which will help you like manage billing, um, manage everything, so having them separately and everything. So that's one of the advantages of putting all the things that you need in a resource group. So like I said, it's a collection of resources that share the same life cycle, permissions, and policies. So we'll not be creating a new resource group because I already created one for this demo, right? This workshop. So I'll go ahead and just keep that. The region also, once it's loads, I'll just refresh. But normally you see East US2 or East US, West Europe. You can use East US. I mostly use East US. Previously, I used West Europe. But with East US, most times you have much more resources and tiers available to you, right? I'm not going to draw so much time explaining on this, but basically, you have things called data centers, and then those data centers are in certain regions and stuff like that, you know. So when you say the cloud, they're actually data centers, and different data centers have different things available, right? So that's what all this does mean, just means. So you can create a name, right? Type in whatever name you want to name your resource. That is still the document intelligence resource, and then select the pricing tier. I already choose the paid standard SO tier, since we're going to be working with much more number of pages. For the free tier, you have 2 pages. You can scan only 2 pages at a time, and then you have, I think, about 1,000 pages free per month or something. So We can check out the pricing for that later, but let's move in. So I already created this, right? AI integration. So um, once we click on that, we can now go ahead and visit the Azure Document Intelligence Studio based on what we've created. Okay, so do we have any questions so far? I believe we don't. So like I mentioned, if there's any, please just kindly drop it so we can work together. So I can go now to the Azure Document Intelligence Studio just to have a visual overview of how this tool actually works, right? Before we now go into code, how we can leverage, do it programmatically and for you to build your solution. But for you to get a visual understanding of how it actually works, which is where I got um, my screenshot with I shared to explain OCR from. There are different templates that you can find there, and then there's also you can also upload your own documents, right? You want to test how you can. Maybe there's a very complex image that you think that maybe Azure Document Intelligence might not be able to like work with, or just want to experiment to see how well to extract it, right? You can upload your own files and see how well it will extract it just to get a visual view, like I mentioned. So while this loads up, we can check through again, like I mentioned, so we can follow along together. You can go ahead, get this link, clone the repo um, while we get started. Most of what we'll be working with is inside this notebook, right? Most of the experiences will be inside the notebook, and then I'll walk us through a deployed solution, right, that leverages Azure Document Intelligence, which was built sometime in October, an open source project um, um, through MLSC Nigeria, which I put together. That was October, towards October 1st. So I'll walk us through the solution and the code, and I mean, just a simple demo. All right. Okay. Seems like would have to wait a few more minutes for this to come up. But let's just get started then, so we don't hang on for too long. So while this is loading up, let's walk through Azure Document Intelligence programmatically. So the first thing that you need actually while working with APIs in general, because in this case now you want to leverage it as an API. There are different things, there are different SDKs. I believe we know what SDKs are. Software development kits, right, for different resources. So just like you have for OpenAI, there's a development kits in Python, for example. We're working with Python. Excuse me. We're working with Python, so we're using the Python SDK. And then how you can actually connect to these endpoints using the SDKs or programmatically generally is through your keys and endpoints. And we'll be using this um, to connect to our Azure Document Intelligence resource that we've created online here, right? So now, how do we get this keys? So from the resource that you've created, you can directly see the endpoints here, right? But yeah, you can go ahead and click this to select your endpoint, and your .env, you can add it up, right? And then you can click this manage keys. Click here to manage keys. Then you see different options. So key one, key two, the region and everything. So you can decide to use any of them, right? So once you copy this, you can go ahead, create your environment, add it to your environment variables. I've added a sample here already too. So as you copy, you can just paste them directly. So it would work the same way for you. You don't have to like really tweak some things. So that is all that has been set up here already. So now we're going to assume that we've created a resource, we've gotten our endpoint URL and then the key, we've added it to our code here, and then want to like test how we can actually use Azure Document Intelligence. So From the documentation, which I mentioned that I shared the link earlier, there are so many models that you can use. But for what we want to do, we're just going to use the read model for our extractions. There are so many other models. You have the layout model, you can see US tag. So let's say you have different documents, different layers. Maybe you want to extract things from a receipt or from an invoice or things like that. You know the way they are structured, right? You can use Azure Document Intelligence. That's, I mean, the more reason why it was called Form Recognizer before, right? But now it has been expanded to even more, do more capabilities and stuff like that. So it's Document Intelligence in general now. So if you have different forms, you can use Azure Document Intelligence to extract them. And then let's say you have your own custom invoice or custom document that you want to be able to like extract them. Maybe you want to create a solution, maybe in your, for example, in a supermarket or something that can just read through the invoices and extract those documents and maybe store them somewhere, right? Within, or maybe on the counter or something. You can use Azure Document Intelligence to power that with the custom capability where you can have your own different invoices, upload the images or do with code, more or less do with code, and then train your own custom document intelligence model or your own custom form recognizer model that can extract the contents of your form um, with less, no much input from you. I mean, you don't really need to know how to build models and all that. You're just leveraging the pre-built document intelligence model to like improve it to now be able to like, okay, this is my own to follow the layouts of of your um your invoices or receipts or whatever it is that you want it to extract. Um, Before I move on into the code proper, can anyone still hear me? Are we together? All
Yeah.
right. Okay. Thank you very much, Miriam. Okay, so let's get started then. So we've already gotten our keys, right? And then loaded them into our environment variables. And then with code, this is basically how you load your Python environment, your environment variables in Python, right? So all these are already in the repo, so we can just follow along, run the cells above up to this particular point, right? The functions, these functions have been added also. And the beautiful thing is that I didn't write these functions myself, right? I just picked them up from the sample codes in Azure SDK for Python. So, like I mentioned, there are different SDKs, but this is one for Python. You see different sample codes on what you can do. Of course, they are not exhaustive. So, if you are going to build a bit more complex things or things for your own use case, you have to like repackage them to suit you. But then for the basics and like foundation of whatever you might need, you definitely find a sample code here in the Azure SDK for Python sample. That's if you're using Python, and another document intelligence SDK. So you can see different things that you can use document intelligence for, barcodes, extra formulas, like I mentioned we're going to cover, analyze receipts, we're going to use the read, right? So if you open this analyze read, you'll see all these functions there, and this is exactly where I got them from. So it's not like I coded them from scratch or something. I mean, coding them from scratch is also nice, but I didn't do that. So just to show you the ease of how you can work with Azure um, services, Azure SDKs or whatever they are, easily without much racking up your head of knowing where to get started. And then, of course, you have Copilot there too to aid you in your um, development. So let's move in straight into code fully now. We've added our environment variables, and then we've also imported our libraries. All the required libraries are already in this requirement.txt file. So once you have the repo, you can go ahead and just run pip -r install pip, in, pip install -r requirement.txt. Basically, you're telling to read from the file and install everything there. For those that are for most of us that are familiar with Python, we are very familiar with this. line of code generally when you want to like learn from repos or something, or you want to reproduce a code. So we imported the libraries as well. You can see you have some starter codes here also to explain different things, which I already added to the slides, right? So we move to the Azure Document Intelligence um, documentation. We can check some SDKs. Let's say we go to the Python SDK, which is what we're on. You can see some sample codes. Then with this properly explained on, okay, this is what this does. We're trying to do using layout. We are using preview to invoice. There are sample codes. All that we walk through now, how to get your keys and your endpoints. Everything is here. The library, the version that you should install. Basically the whole setup and everything. So you can just pick this up and tweak, test, get yourself familiar, and move on from there. So documentation is usually always recommended for whatever thing you're actually building. So, and Azure Document Intelligence documentation, or Azure documentations for all their services in general are usually really great. So, it's a good starting point. But we're already covering most of what you find there currently. So, but you might not have to go through all that stress. Of course, you need to like maybe improve on some things. So there's a sample um, file here that Azure also provided. And then from these files, you can just, using the previous read to analyze the document using the URL. So you can either use URL, like maybe your file is stored somewhere on the web, right? You can get the URL and extract, or you have the files locally. For the demo now, we're going to be working with files um, locally, right? So we have that. We run this function. All this, like I mentioned already in the notebook, we run this function, and then we can display what is extracted. So this is the URL. Let me just copy it and load it in the browser so we see exactly um, what is there. And then we compare it to what Azure Document Intelligence has been able to extract. So this has finally loaded. Let me click, try it out. And why that is on load this image so we can see the content. Oh, okay, nice. It's the exact same sample that I shared with us. So So we have this document and we want to see how well Azure Document Intelligence is able to extract it using the regions dimension that it works with to extract them. So now we've run this and then we're going to see the different things that we printed out. So it just shows you a few things, different stories and all that. And then you can scroll through. Of course, this is not entirely very readable, but by the time package everything, you'll see them in a better representation. So this is showing you all the words that have been extracted, all their positions and things like that, right? So and then how sure it is that that is the word that is extracted. Like I mentioned, it's not in readable format or a writable format. So it's actually looking at it like a human being is going to read and then extract the document. So definitely there will be a confidence value because it's perceiving, right? It's not outrightly saying this is it. So we have all that, just a simple sample of okay how it extracts, and then we'll look through um, visually here how that works too. So we'll use the same loading documents this read healthcare file, which is the same thing that we have here. We'll run the analysis, then look at the several segments that Azure Document Intelligence is able to split it into, and then pick up from there. So now, but first, let's move into our own demo, a full proper demo of Explorer. So we'll get started with exploring formula extraction. So most times for RAG solutions, you are just working maybe with pure text and things that, okay, question and answer based like that in those terms. But if you want to go further, maybe build something that maybe has some math capability, maybe you can recommend, okay, use this method or this is the formula you have to use based on maybe some textbook or something. and then it's like it's sort of, because it's called a kind of question and answer solution that you're trying to build, right? But then it's able to like actually like know that okay, this is a formula and not just underscore and arrow and different things pointing to each other. And it doesn't see it as a text, right? With Azure Document Intelligence, you can do that. So I have this sample document here, which I'm going to open. It's a snippet from Paul's online notes for a few of us that do engineering. So this is a section from the partial derivatives of the textbook, right? It's something you can find publicly online. So things like this limit, if you use traditional OCR models to extract them, it's going to really fumble because it can recognize all these superscripts and all that, right? And the way they are aligned. But with document intelligence, it can pick up, okay, this whole region, right? See, even highlighting it, it can't pick everything properly. But let me say I try this, okay, fine, it pick this. Highlighting all this, it takes it as a formula, and then by the time you're outputting it or inputting your solution, it's going to extract it as LaTeX, right? So all this is just like, I mean, simple terms, not too complex. You can try with more complex formulas. I have for some solutions I've worked towards building and built. You would see the capabilities that it has, right? Even more complex formulas are maybe like 3, 4 lines and different symbols touching each other and all that. So it extracts them in LaTeX format. And then if we run this particular cell, which has been run already, and we move into this portion, which loads, it just basically extracts the results from the analysis, right? When we analyze the file, and then saves it in the dictionary. So that's basically what I just did here. And then we go through, right? This has been saved already. If we go through, we can see all the different. So this, of course, this from the first part, the full content of every single thing that it extracted. Um, 13 partial derivatives. See that there's a new line. To this point, with the exception of occasional section in the last chapter, that's the same thing that we're having here. To this point, with the exception of occasional last chapter. So everything has been extracted. As you can see, let me just increase the size of my ES code just a bit so it's a bit more um, legible, right? So all that has been extracted. But now we're looking at the formulas, like what are the formulas that are extracted? So let me search so we can see the first formula. It's that's the formula. Okay. This is so basically all the parts that it's got as formula, that's how it represents them in the text. So it means that this portion, what was there was a formula, and then it has just represented our whole place as a formula. So if we look at the first formula that it extracted under formulas, you can see limit and this and this and this too. And this is in LaTeX format. And if you copy this, and let's say, can I open GPT here or something to represent it visually? We'll see that it's also, but let's compare word to word first. What is the first formula possible that it extracted? Okay, this is the first one. So you can, if you compare, you see limit x, right arrow tending towards a something something, right arrow towards a, right, and then left x equals l. So this is what we have here basically, and if we try and paste it into maybe a language model, or let me even test with my what I call it now, with Markdown. Of course, Markdown is not purely just for LaTeX, so it might not be perfect. But we paste it in Markdown and see how it represents LaTeX. We see that okay, it's not even picking it as LaTeX at all. Um, how do I run LaTeX in? Let me open GPT. Yeah, ChatGPT.com. So I'll paste it in and I'll tell it to display it to me as a full text. So So display. So I mean, by the time you're using code or something, you know how you want to render LaTeX code. Of course, Markdown is not very for LaTeX. Markdown is Markdown format. So let's just say display this LaTeX file as normal. So I'll click that and I'm just going to wait for it to give me a response. Did I send anything? I'm send this display content as normal. Okay. So yeah, you can see it's exactly how it is in the textbook, right? And that's what you can, that's one of the capabilities of Azure Document Intelligence. If we check for the next formula too, right, this one is even much longer, right? Let me do the same. Let me just copy this whole thing. Uh, so if I copy this whole thing, and then paste it again, uh, do the same for this. Okay, here you can see that's exactly the same thing also here. So that's one capability that we run through now that you can do with Azure Document Intelligence. And if you see from my code, what I've actually done is that, you know, I mentioned that all the portions that have formulas are represented as formula in the text. So every place there's a formula, it will represent it as column formula. So what I do is that I replace every occurrence of formula with each of the formulas. So um, and my function that I've defined here to extract the text and formulas all together, I extract the text first. I mean, I extract the formulas, store them in a list, right? These are everything here for page of formulas and formulas, which you would have seen from here, and then I extract all the content. So the next thing I'll do is all the places that have formula in the text. Of course, those places means that the formula has been extracted and has been stored somewhere. So I retrieve all of them, right, and then replace them with the actual formulas in LaTeX form. So that was happening here, and this one basically means that I should not replace every single thing. So normally in Python, when you use replace, it should replace every occurrence of formula that you find. I mean, of this matching text. But with this extra argument, right, it means only the first occurrence of this string match should be replaced. So each formula will be represented and then replaced appropriately. So that's one beautiful way we can leverage Azure Document Intelligence for formulas. And then maybe you have to build a math related solution and things like that, right? It will be good for you to leverage this for such solutions. I mean, it could not even just be RAG, it could be something much more beyond RAG, right? Something that you want, maybe you want to convert a document, like a PDF document that is, you know, you cannot maybe extract directly. Maybe you want to create it in something that you can write a write format, like maybe the text or Word document or something. You can use this to do that. And beyond just PDFs and images and stuff, you can use Azure Document Intelligence to read and write from docs, PowerPoints, and different things like that. So we run analysis. Now this is backup, right? If we run an analysis and see how um, Azure Document Intelligence is able to extract that's visually now, right? Since we just did that with code, we want to see visually. You can see that it's able to identify these regions. Normally, in traditional OCR models, right, what happens is that it goes line by line. So in your traditional model, we do a comparison, which we would not do at this point, but you can test out. Maybe you just use PyPDF or something to test out one of those maybe open source. Of course, there are more better and maybe complicated open source models. So I'm talking about the baseline ones now that are very, very much common that you use, like compared to those sophisticated ones that are being built now, which of course includes document intelligence, but that's it's not open source. So we have if we're going to use a traditional OCR model, to read. What would have gotten out is, as a pharmaceutical and other life sciences organization, as pharmaceutical and other life sciences organizations invest, Tandem was able to create and deploy this innovation by, that's most likely we're going to get. You just see that a space was represented here and just continued reading line by line. But Azure Document Intelligence is able to understand that there are different regions here, right? Which is what it has done here, identifying the different segments and extracting it based on that particular segment. So if you scroll through here under content, you see this first part, while healthcare and everything, that's detected that at the top frame, it moves to the next word, where the name and the title of the person is, the first paragraph, this enhancing the patient. So it's able to extract everything. You can see the results in JSON format, which is what I just showed us here, right, when we were exploring this analysis of JSON. So this how the output would be programmatically. Then you can now use the SDK to extract which one you want. Maybe you have extracted formulas or handwritings and different things, right? So we can see it's almost the same thing here, which we have here. And then code, there's also a code sample for you to pick up from too. So like I mentioned, that one makes it very easy to develop solutions with Azure generally, because it's always easy for you to just pick up from somewhere. See the sample code now, you can just pick it up, tweak it to your documents, which is basically what has been done here. Change, they're using preview to read, they added this file, maybe you have your own URL somewhere, you don't want to use the sample layout, add the URL to your own file, just test out, experiment, okay, this is good, then you now package it to what you want to do fully, right? So next, we're going to see how we can extract text. That's just normally. We've extracted text and formulas, but if you just wanted to extract text alone, right, you can check through here. Um, I have a sample function too that just does the extraction. You run through, get your results, and then it writes it to a TXT file. So let me open the second snippet I have. So the second snippet I'm using is this WHO document, right? Just a portion of it. And you can see from the portion of the document, there are different sections. It's just like the previous one I showed us. Some are on the left, some are on the right, some are circled and things like that. So you can see this by the time we get to this page here. You can see they will have a table here, one section here, another section to the right. Then there are some that the portions to like this action one. There you have 1, 2, 3, 4, 5 bullet points, but you now divided the page, right? Normally you don't want to just read diagnose heart disease, stroke, TIA, alcohol consumption. You want to take this section first, right? Then take this next section, right? And that's with document intelligence you can achieve that. So if you run this code on your own end, like the files are there already, so you don't really need to change anything. Once you run these notebooks, you will get the same results. And I've saved it in this text file here. I named it as extracted. So we compare from page one, right? If we compare from page one, see that it extracted, okay, first, World Health Organization. Let me open this side by side. World Health Organization, implementation tools, package of essential non-communicable. This is a text file document that is readable. So you can see that I picked this, instead of saying package of essential, a new line, non-communicable pen is this a new line. It understood that this whole thing is one, right? And extracted this as one thing. Extracted it as one thing. Not saying, okay, this is new line, new line. So it's just reading line by line. Once you get to a new line, it terminates and goes to the next line. You can see that that's not what it's doing there. It's taking the whole portion as one sentence, or sentence, or whatever. There are multiple sentences there. It takes our whole context there. That's what is happening there. And then by the time we scroll through, let's scroll through the pages that have some more complicated layout, right? Yeah. Let me scroll down to the places that have some more complicated layouts. Let's say this part now, action one, ask about. So let me search for where action one is here, and we'll see how it has been represented. Action one. We'll see how it was able to extract the different portions. So you can see here it says action one, ask about, right, straight up, and he stopped there. Then the next phase was, the first point was diagnose heart disease, stroke, kidney disease, and he picked it out as one thing. You can see that he didn't go straight to this next. And after that, he went going to alcohol. It picked this whole sentence as one. Then he moved to this first. This is just right side, and of course that one is it's. But you shouldn't. I don't know. But for visual appeal, it's okay there. So it extracted that. But subsequently, every other thing was straight up the way it should be. Anginal, breathless. So like typically, you might say, okay, this first visit should have been extracted first, and then action one, ask about will now come in second. But it didn't see it first. So it went this, and then the next occurrence was this point. So it okay, he identified the segment and picked it up. But you can see subsequently everything was extracted in order. Anginal, breathless, on exertion, and laying flat. You get it. And then after let's just scroll through, after going to this current tobacco use, right? After going to this current tobacco use and everything, it extracted it. You can see that it goes next to what alcohol consumption. So it knows that after this section that I've extracted, the next place I'm going to go is here. It didn't go to the next page and like skip it and going and maybe straight down, then that goes and comes maybe straight down the left, then now straight down the right. It identifies the regions, the order in which those regions appear and follow each other. So that's basically what is happening here. And we can see how well it does that with this simple demo. So this basically how you can get started with Azure Document Intelligence with this sample codes that have been drawn out here for us. And then, like I mentioned, you can also do handwriting recognition. So if you check this sample codes in the Azure repo for Document Intelligence SDK, you see a sample where you can analyze handwritten text. So under this, you can see their styles, document analysis feature, style font, right? What you want to extract. And you can see here, once you go under, once you extract the styles, you can see, okay, this particular text is handwritten, and then it knows how to now represent it. Because not like it knows how to represent it, but it is built to you to recognize that. So you're expecting that, I mean, I've given it that feature that, okay, please, if you see a handwritten text, treat it as a handwritten text. Don't just read it anyhow, right? Because the way you read a handwritten text is the way that you read a normal text because of the appearance, so that you don't misconstrue some letters and stuff like that. So basically, that was going to be happening there. And if we look at the sample image that was used for analysis here, let me get that link. Okay, which I did I open it here. This is inside the repo. Form one. So if I go to form one under the sample forms, there are portions that are handwritten. There are portions of the image that are handwritten. So if you see this, when we scroll down to the signature here, Benny Sanders, you definitely know this is handwritten, right? So if you're going to read this normally, as you know, this is a very, very nice handwriting, of course. So it's an outlier, but of course, there might be some more complex handwritings. Not it doesn't have to be, yeah, not it has to be legible at least, not something that nobody can read, even a human being cannot read. If a human being cannot read, then there's a higher chance that a machine or an AI model might not be able to read it too, right? So for example, you have this, it detects that it's a handwritten text and it can extract that properly. So many um, possibilities you have, right? And then to finally wrap up, before I take questions, the simple demo that I mentioned that I wanted to walk us through, packaging all this into a RAG solution. And what I'm going to use to run us through this is the Speak to Docs project, which I mentioned. So it's a RAG solution that allows you to, upload maybe certain documents, and then you can either text it to give you a response or send a voice note. So that's why it's called Speak to Docs. So you can speak to it and it gives the response in sound too. So, but if we go through this code under RAG functions, right, most of this part was done by this particular contributor, Miriam. The person is actually on the call also. Yeah. So for the contributors work, right, which is of course that has been set up already that document intelligence is to be used, and then for the challenge, we're in constant communications with the contributors. So that's one benefit of contributing to open source projects and actually even working on them. So of course, in this way now, you can now fully leverage the power of document intelligence for, of course, just a simple application, nothing too complex, right? If you see this part now, which is like similar to the functions I've created in mine, where you can extract the content and everything from here, you can see some similarities here where you have passed in your keys and your endpoints, and then you've drawn up this analysis client to analyze um, the document. But take note, this is an older version, so it still uses the Azure AI Form Recognizer SDK. The most recent version is the Azure AI Document Intelligence SDK. So, but of course, there are many similarities, and you can also go and check through the sample codes in the repository that I already mentioned. So we have this it sets up the client that'll do the extraction. We're trying to check, okay, is it a PDF first or is it a text file? If it's a text file, of course, you don't need to process anything, it's readable straight up, right? But now we're focusing on PDFs because we can't write from it or extract things from it. So we want to process it as a document intelligence. So the file is passed to the Azure Document Intelligence client, which is begin analyze document, which is the same thing that you see here, right? Begin analyze document. It's the same code sample that I shared with us. So they are not so there's not so much difference. And then when this is extracted, the results are now like put together. So all the contents and everything are put together as a text, just the way I have written all of mine here into this .txt file. Like you can decide to maybe format it better, add more spaces. So because it reads the portions and it builds it out. Maybe you want it to maybe have more visual or something. But directly, these are already separated by new lines, right? But maybe you want it to look more readable. Of course, but you don't really need that because you are still passing it to your model. Your model will be able to whatever trunking strategy you are using, will be able to tell that, okay, these lines are separate. Looking at it, you might think they're all together, but maybe you want it to be more separated like this. So like the spacings are like very, very nice and stuff. You can do that here also, which is what um, this contributor did, adding this new line so that they are more separated, and maybe when you open them and check before you now create your vector store, right? You can see clearly what is happening. So we have that. And then once all the extractions is done, I mean, yeah, all the extractions are done, all these extract contents from documents, right? You can now create your vector store. Right? So all the process of creating the vector store is done. So you check the main script, you see something like the docking array in memory search, which is a LangChain um, form, which is a LangChain form that you can use to um, store like a vector store basically in memory at that particular moment. So it's not like it stores on the cloud on the cloud or something or locally. It's just about to say if you are working your code and you want to experiment with a vector store, you can use this. Once you close your laptop or something, or you shut down the vector store that has been saved within that doc array memory set is cleared also, right? It's just for that moment. So, and with the way Streamlit works, with the approach was defined for this project to use that best since you're working in sessions and Streamlit works with sessions. So all your context, all the vector DB will be saved within doc array memory for that particular session while the person is using the website. So you can see that you first have to like upload your documents, the vector store is created, create vector. So you can see all these functions that have been defined, and then the embeddings have been extracted, calling this function, right? And then the documents being passed. So once you upload your documents, there's a function where you upload your documents somewhere here also. Okay, under the sidebar, once you add your files and you upload them, you see that a function that is called, a function is called to embed them. So file check num, you can see, you would have seen it in the other functions, other functions, and then the processing is done, extract content from docs. right? So you can just walk through this repo to see the whole full end-to-end process of passing the document into um, the vector store using Docker memory search, right? So yeah, that's mostly it, right? And let's walk through a simple demo of how document intelligence works for such a case like this. For this particular one, it's not built to handle formulas and stuff you get. So what I'm going to test it with is just the pure text WHO snippets, right? So I'm going to upload this file here. And once I upload this file, you'll see some processes run, which is going to extract the process of extracting the document, the process of document, the regions, identifying the regions, just basically how document intelligence works, extract all those regions, and then passes it right to the vector store, which is the doc array in memory search already mentioned. So now this file has been uploaded. I can now ask my question. So let's just maybe go through some things. What could I ask that aligns with this referral criteria for? Let me just look for a simple question to ask. Okay, how can I stop tobacco and avoid harmful use? Let me just pick this. How can I stop tobacco and avoid harmful use of alcohol? Let's see if it will recommend me the steps that it has extracted from it. All right, so you can see it gives the response. To stop tobacco and avoid other harmful use of alcohol, you can follow these steps. For tobacco, reinforce that tobacco increases the risk of health, which is similar to what is here. Encourage all smokers, um, blah, blah, blah. Assist employer in the quitting plan. I mean, is there a quitting plan somewhere? Let me see. Abstinence. Let me um arrange the follow-ups. Let me search here. Probably maybe the answer to my question has not even been picked from this portion that I am. Let me search for quitting plan something. English. That's all. It's quitting. All right. Okay. So tobacco use increases the risk of developing a heart attack, stroke, lung. Quitting tobacco use is one of the most important things you can do to protect your heart. So you can see that where I wasn't even actually where it picked the answer from, right? So it has understood the context of what I'm asking, and it has selected the most relevant portions, right, of the document to answer my question, right? So assess and prepare a quitting plan. You can see it selected that from here too, which is what it explained for. So where I was even thinking that it's going to select the documents from that are most relevant, it didn't pick them from. So you can see that it understood this block flow diagram that is talking about, okay, do you use tobacco? Yes. What advice? It could understand that context here. I mean, that's from the vector store. But because the way document intelligence has already extracted the different portions, it was able to draw that relationship. Just reading line by line. AI asks, do you use? No. Reinforce message that tobacco, no. Tobacco includes risk. That's probably how your typical OCR model would have read it and studied for you and pass it to your vector store. But because document intelligence understands the different portions, it was able to extract those segments, those regions, identify those regions, and then give you an output. If I take a quick screenshot of this page and see visually how document intelligence will analyze it, let me do this. And then if I take it to document intelligence and upload, we can see how it will then analyze it, and then you see why it's really, really nice to use document intelligence for the OCR part of your RAGs solution. So that's wait a few seconds for this, and we'll see how I was able to identify the region. So you can clearly see that it knew that, okay, this AI asks is one portion. Do you use tobacco is one portion? No, is one portion. Reinforced message, blah, blah, blah. There are different portions. So with this now, the layout is much better. So you can even see the way it has extracted it. AI protocol of Amike, ask, do you use tobacco? No. My first message, AI to advise. So it is able to detect all those segments and pass that to whatever tracking process they are doing. Maybe you are splitting, I mean, 1024 tokens or whatever it is. The output of your OCR is neat and clean already. So you have better responses from the RAG solution you're building. So these are one of the so many things you can do with the Azure Document Intelligence as regards RAG solutions. There are so much more, but of course we cannot cover everything within an hour. So I would like to stop here for now. And if you have any questions, please um, kindly maybe unmute and share. Thank you. Okay. I'm assuming there are no questions, or is there maybe anything in particular that we found interesting that we gained? Anyone wants to share anything or some insights, basically?
Hi, good evening, sir. Good evening.
Yeah, good evening.
My name is Sadwashio. I'm just an attendee. Uh, but there's something is in my mind. There's this tool I'm familiar with, Microsoft Power Toy. Yeah. So I was actually thinking, will it have done the same work with OCR in either RAG solution or any other solution? And that's my question because I'm just thinking, because I know that Microsoft PowerPoint can do um, text extraction from screenshots, from images, and so I don't know. Maybe it can do as much as PDF and other big documents. So that's why I'm asking the question. Thank you.
Oh, okay. Yeah. For the service you've mentioned, I've not used it so much. But thank you. If I heard you clearly, referring to maybe capability in Azure Power Apps or something, right? But for OCR, the Vision service and the Document Intelligence service are dedicated AI services for OCR in terms of Azure, right? AI services or Azure in general. So the capabilities you get from these two services, I believe, right, will definitely exceed this one you've mentioned, and it could actually even be leveraging um, the capability of these services. So, like for example, within Azure AI set, you can optionally include AI enrichment, and this AI enrichment would need you to create an Azure AI service multi-resource that will now pick from Azure Document Intelligence, Azure maybe Vision service to power whatever extraction that is going to happen within Azure AI set to create your vector store. So this tool you've mentioned, this resource you mentioned, could actually in the hood, right, in the background, be leveraging these tools, right? Because these two, like I mentioned, the Vision service and Azure Document Intelligence are dedicated services for OCR for different forms of documents, images, and things like that. So, yeah, I hope that answers the question.
Yes, sir. Yes, sir. Thank you so much.
Thank you. Any other question or any other thing anyone wants to share? Okay, I can see Miriam is typing. If you cannot unmute, you can definitely go ahead and type also. Okay, so while I wait for Miriam's um question or remark to drop, um in case you have any other things you want to share, please kindly you know, unmute and speak. And then just to round up, while we wait for that, I would like us to fill um, some survey of how you found the session. Right, it's just a two-question survey. I'll share the link also in the chat right about now, in case you can't scan. Right, so it's just a survey to gauge how you found this the class. I mean the workshop. You can call it a class too. I don't know how you found the workshop, and then how you how do you feel about AI generally based on the session and Microsoft technology. So you can scan this QR code. I've also dropped the link in the chat. So please, this will take about maybe 30 seconds or a minute for you to fill in. So please kindly check that out. So Miriam shared that. Okay, she says, I'm quite excited to use the Azure OCR for my next project, or you can say Azure Document Intelligence, right? The formal extraction portion is exactly what I'm looking forward to use. Okay, nice. Thank you very much for sharing that, Miriam. So guys, please do fill in the link and then share your remarks basically through that. And if you have any questions or any remarks, you can drop them or unmute. Yeah, thank you very much for attending the session. So we're going to end it's here. Um, you can also still reach out to me maybe via LinkedIn or um, for those that know me personally on WhatsApp or something. If you have any conversations you want us to have as regards this, or maybe collaborate on project or something, I'm really, really down to that. So yeah, thanks for taking our time to join in, and I hope you gained a few things that will be helpful in your AI career and whatever projects that you're working on. Bye.